Hello, everybody. Good Sol. We'll be doing a presentation about human return to moon. I'm Professor Julio Rezende. We are. This is this is this is part of our space analog mission 211, happening during July of 2025. And yes, it's very welcome. Bring this discussion about human return to moon during the moment when we are celebrating 56 years since the man landed on moon. Okay. Okay, continuing my presentation. Uh, One of the topics very important to think about human presence on moon is related to solar radiation or cosmic radiation, how this would affect the human settlement, how this would affect the human health. And on the moon, solar radiation poses significant risks to human settlement, primarily due to the lack of substantial atmosphere and magnetic fields for shielding. This increased radiation exposure could lead to one moment to radiation sickness, increased cancer risks, and other health problems. Okay. Okay. One moment. Okay. Mitigation strategies such as using underground habitats, lunar material for shielding, and teleoperated devices would be necessary for safe long-term human presence. Related to radiation hazards, the moon surface has much higher radiation levels than Earth due to the absence of protective atmosphere and magnetic fields. This radiation can cause deterministic effects like radiation sickness and stochastic effects like increased cancer risks over time. Also, shielding challenges are a spacecraft and habitats would need robust shielding to protect its settlers from radiation. This could involve thick layers of lunar regolith, the soil, and also underground habitats or advanced materials with high radiation absorbing properties. Some health risks are related to a possibility of cancer, central nervous systems problems, and degenerative disease. Some mitigation strategies are the settlements would incorporate strategies to minimize the radiation exposure. These would include underground habitats, burrowing with lunar surface, providing natural shielding against radiation. The lunar regolith shielding would be a good strategy to moon. Also, this would incorporate the support of teleoperated robots. Also, you can see the necessity of energy. Solar radiation is valuable energy to the operation. We are also would be considering the use of kilopower technology like a nuclear fission plant. Also, one other challenge is related to temperature extremes. The moon experience extreme temperatures fluctuations between the day and night, and the habitats would need to be designed to regulate temperature and protecting inhabitants from these extreme temperatures. There is a very interesting article from NASA. NASA identifies candidate regions for landing next Americans on Moon. Also, I'd like to show these are the sites: Faustini Rim, peak near Shackleton, Connecting Ridge Extension, Helarc, two sites. And also one of my next slides will be bringing more details about this map. Each of these regions is located with 6 degrees of latitude of lunar south pole and collectively contain diverse geologic features. Together, the regions provide landing options for all potential Artemis 3 launch opportunities. Okay, it will also be showing these more details about these sites in the next slides. To select regions, agency-wide team of scientists observed the data provided by Lunar Reconnaissance Orbiter and also decades of publications and findings from lunar exploration. Okay. Also, some features to be considered would be safety landing place using criteria including tenuous slope, ease of communications with Earth, and lightning conditions. In this case, we'll be talking, also showing these 13 regions that will be considered for a possible presence on Moon. Here we can see like in the South Pole, here around this area. And also you can see these 13 different sites. And now more details are like connecting ridge extension, connection ridge, the Gerlach Ring 2, Gerlach Ring 1, Haworth, Malapert Massif, Leibniz Beta Plateau, Nobile Ring 1, Nobile Ring 2, Amundsen Ring, Faustini Ring, also peak near Shackleton, the Gerlach Cocker Massif. And now, in this case, this would be these very interesting 13 sites, 13 areas that we'll be considering, and also in the South Pole. Probably it's avoid the equator, because in the equator of Moon will be exposed to a higher radiation. In the poles would present safer conditions related to uh, minor quantity of radiation, cosmic radiation, solar radiation, and also deals better with high extreme temperatures, because we imagine that in the South Pole or in the North Pole will be more balanced the distribution of temperature here. In our proposal, we are imagining a station with 7 different facilities. In this case, we are proposing like on the ground, on the surface, this station. And we also, for the methodology of our Space and Log virtual missions proposed by Habitat Mart Space and Log Station, we are inviting our participants to imagine a station with different main facilities: the launch center, control, the main station, the health facility, the greenhouse, engineering facility, sanitation center, and also the power station connected to grids, like a grid of different sources of energy, like solar farm and kilopower energy plant. Also, we are considering as a logistics system the Starship to be landing and also contributing to build this station on Moon. And in this case, is a little bit different from the current Artemis program, because in the Artemis is proposing the use of SLS to build the station on Moon, and in this case, we are proposing something different related to the use of the Starship. Here, a concept about how the parts and also the components of also vehicles that will be delivering on Moon, and how they would be delivering, and how would be the displacement and the construction process. So yes, and also this Moon habitat concept, we invite the participants in the Space Analog mission use some different possibilities to design the station. For example, uh, design this possible station on Moon using as architecture and design programs like SolidWorks, AutoCAD, or other CAD program. Also, you can represent this station on Moon or this specific facility on Moon using programs like PowerPoint. And the third possibility is you designing a paper with a pen or with some, you can use like pencils to design the concept of this station and take a photo and later do the upload of this image to your presentation, okay? Our facilities presents a circumference shape with 8 meters of diameter and 3 floors or 3 levels. The in-space design of infrastructure is very important. It's a great contribution presented by you when for our participants during space and log missions. We are considering that each specific facility contains a dormitory with beds for astronauts of your facility, a small kitchen and dining room, toilet, a small vertical garden with plants for meals, and 3D printer. Uh, Instead, we have like an entire station. We imagine that each specific facility presents some redundancies in terms the own system, because if you have like a problem in the part of the station, these specific facilities would present like a redundant systems to be operational with the possible collapse of all other parts of the station or some difficulties in other parts of the station or moon. And also it's the sectors or the facilities of a station would present the all possibility to be operating as a self-sustaining system. This is important to think and how would be the redundant systems to support the self-sustaining operational activities of these specific facilities. Here is considerations of design of the habitat. These would be like expandable modules that would be transported inside the Starship. Also, the Starship presents a payload area of 9 meters of diameter. In this case, we are considering the segments transported inside of 80 meters to be possible to take out these components for the station, as we can see here. Later, since these electronic columns extended, we have a concept like this, like represented by these images. Also, this was a proposal of an architecture from India called Yasharato, and he imagined the possibility of this design. And also you can see like a possibility of like an inflatable habitat, expandable habitat that would be easily transported from Earth. Also the corridors, how would be these corridors connected different infrastructures. Also imagine a garment called Vectran. Also, this garment called Vectran was used by Bigelow Aerospace to operate the inflatable habitat connected to International Space Station. And this inflatable habitat is operational, and connected to International Space Station. Probably they are examining how radiation is impacting and how is the quantity of radiation is transpassing this material and impacting inside the structure. And this is interesting because they can evaluate if this kind of inflatable or expandable habitats is safer or not for the astronauts related to possible impacts of radiations for human health. Also, here it's interesting to see the expandable habitat of Bigelow connected to International Space Station. This structure is over there. Also, a report about Bigelow expandable model goes into overtime on a station. It's very interesting. And this is the company, Imatec International, that is developing this garment. Okay, it's like a polymer. Okay, this is a concept that we are bringing for our participants during Space Analog virtual missions, but there is the possibility of different possibilities of design and concepts. Okay, thanks so much. I'm stopping the recording.